Hello, good afternoon, everyone. Uh, Today in this lecture, I will be going to explain you uh, algorithm by which we can find a target sum from an array. It's a most asked questions in interview, and I will be going to demonstrate how I am approaching this. And there are many approachable decisions you can take and algorithm you can work on, but for me this one suits the better. So let's start. So what we are I will be going to start by explaining you the code. And I know that some of you might think that this is a really easy code, and it's not to be it's not to be able to, it's not a teachable material. Yeah, I know that, but I want to start and I want to grow an audience where everyone can move on from the first step. So yeah, let's move on. I'm sorry. So yeah, so I am starting with the initializing the algorithm name and passing in the parameters an integer array and integers target sum variable. So after that I'll be starting with three variables, each assigning to 0. So integer start, integer end, and integer current sum, which will be assigned to the array index 0, 0, 0, 1, 2, 3, 4, 5. So yeah, after this the code will go into a loop, a while loop. It will target until the we are at the array length, so until the end of the number. So first, after that, it will check if our current sum, which is which whatever it will be. In our case, it will be 1 when we are starting from the index 0. So at index 0, it's the number is 1. So it will check if the current sum, which is 1, is equal to target sum. No, it's not. Uh, Otherwise, it would have been 33 would have been is equal to 33. Then it would have print that sum found between index this and this. If we have put like 33 here, then it would have said that the sum found between index 2 and 2, and it will return that. So after that, if if this statement is not true, then it will go on to this statement. It will check if whether current sum is less than target sum. So 1 is less than target sum, then we'll move on to the next. So 1, I will it will move on to the next. So 1 will be going to we will be going to move on to the first index, and on the first index it will be the number 4. It will, if and is less than array length, it will append, it will add the whatever we are the number is it on, it will end so it will add in current sum. So current sum would be like 0 1 0 2 0 3, as like that. Else, if we have if we have expanded the array, for suppose that 33 is the target sum and we have reached 37, 38, 35, 34 more than the target sum, then we're going to move back, because might be some possibilities. There might be a combination which we can go with it, like 23 and 10 will make 33 our target sum. So maybe by 10 and by 5 we'll be going to move on to the we're going to expand, we're going to increase our target sum. It will be increased, so we have to move for like backward. So it will so it the index will go to the array start, index will go to the current sum. So it will be going to do, first it was 0 1 0 2 0 3, it will be 1 3 2 3 until and unless we have found out this combination 23 and 10. At that time, if there are if I've added 47 or some 48 or 100, it will say that no subarray found within the given sum. Yeah, of course we will not be able to find any 100 target sum and of 100 So it's an edge case. I'll be going to explain that in further, like afterwards. So let me explain you how I'm visualizing this. So what we are doing right now is that from the start, as the current sum index value is at 0 0, so the window will be 0 0, and at the indices 1 it will be going to display 1, the number 1. It will check whether 1 is less than 33 or not. Yes, 1 is less than 33. It will going to move on to the next, and plus plus will going to increment. As you have seen, if current sum is target sum, 1 is less than 33, and will be going to increment and will going to move on to the next sum. So 1 and 4 will be indices will be there, and it will make our 5. So 0 and 1 to or from 0 to 1 it will be going to plus all that number. 4 and 1 uh, will be going to summed up, and it will check again. First it will check whether if the current sum is target sum. No, it is not. Then it will go on to this. Current sum is less than target sum. Yes, 5 is less than 33. It will going to expand, and plus plus again it will be going to move on to the another number. So now we have the window of 0 and 2. So 0 and 2, we have 1 4 and 20. These are the numbers between 0 and 2. So that makes us 25. Is 25 less than 33? Is 25 is equal to 33? No. Is 25 less than 33? Yes. Then we are going to expand. So by now we haven't found the number, and the number which we are subarray is not is not increasing more than the number. So we know that there might be some number and we can move forward. So and plus plus is incrementing. After that 0 3. So 0 and 3, between 0 and 3 there are four number 1 4 23, and these are making and after summing them up, this is the number we are getting 28. 28 is less than 33. Yes. Then we are going to expand again. 0 and 4, we are going to move on to the fourth index. 0 and 4, then there are five numbers 1 4 23 and 10, and it's going to subarray will be going to found out as 38. After we have gone to the this index array, the index, and then we have found out that it's we are getting 38. Is 38 less than 33? No, it's not. Then we'll going to then we are then the code will be going to move on to this else statement, and it's going to check if the number is more than that. Then we are going to shrink left, we are going to expand. Start plus plus is going to expand. Then we're going to start from 1 and 4, because I have added this start plus plus going to increment, and after this incrementation we are going to start from 1 and 4 index. From 1 and 4 index we are getting the number 37. 37 is still more than 33, and we have not approached our desired number, which is 33. Then it's still going to it will going to shrink left. Then it will be 2 and 4. Between 2 and 4 index we are finding out that our number is 33 is matching. It's going to first check number is sorry, it's going to check this if statement. If current sum is equal to target sum, yes, the current sum is equal to target sum. 33 is equal to 33. We have found out the number, and then it will be going to say that we have found this and this. I will be going to run this code first with the number our target sum in our array, and it's going to say that we have found out that the number is between 2 and 2 index. Yeah, it's between 2 and 2 index, 0 1 and 2 and 2 index, and we have found out number as in between 2 and 2 index. Otherwise, if we don't know, I'm sorry, then it will be going to say that the number is between 2 and 4 index. Yeah, the number is between 2 and 4 index, 0 1 2 3 4. So between 2 and 4 index we have found out that our target sum is 33. An easy and approachable solution can also be that an example can be window progression or spotlight progression. So what the code is doing is that it's simply an um, it's simply a sliding window approach. So what we are actually doing is that we are shrinking our array size by the code given in our algorithm. So it's going to shrink by the code given in algorithm, and it's doing by if the number is less than our target sum, then it's going to the number till that indices will be going to add it into the current sum. Otherwise, it will be going subtracted from that. As array start will be going to subtracted from that. So it will be going to 142010203, as you have seen 0 0 0 1 0 2 0 3 0 4. By then we have expanded our we have increased the subarray has been increased more than the target sum, then it will be going to shrink left, then it will be going to from 1 4 to 4, and by then it would have found out the number. The time complexity is O(n) because we are targeting each number one by one. So it's that. And the window progression spotlight is going on by one. It will be spotlighted at 1 because it's our array 0, array at index is 0 will be at the number 1, so it will be spotlighted at 1. 1 and 4, then 1 4 20, 1 4 23, 420 because we have expanded our number, and the shrink left part of the algorithm has been triggered. So we have moved on from the number 1 and we have gone on to the 4 23 and 10, and it's still more than the number we are more than the target sum, so it's 23 and 10. And by then we have found out the number 23 and 10, which is after summing up is 33, our target sum. So we have found out our target sum also. So yeah, it's fairly easy um code, and the problem was also fairly easy. If you are still in this video, I would like to tell you that after, as you have seen this, that there are two edge cases forming in this. The first is that that it's impossible to target sum. Like if the target sum is 100, let's suppose if the target sum other than 33 is 100, it's going to say it's going to say no subarray found within the given sum. But what if we don't want this edge case? What if it's not there? So what it's doing is, and the code is doing is, the window will expand to include all elements. Like current sum is 43, current sum is 33. After that, since 43, like our current sum, after we add all of this, then it would be coming around 43. 43 is still less than 100, and it can't be more than 43. It can't be more than that number. So since this element since the element doesn't exist, the loop will end and it will output that no subarray found within the given sum, this line. Why? Because the total sum of this array is 43. After summing all this up is 43, which is less than 100, so it will be always going to say this. And the next case is that the negative numbers in this array is not included. If we add example 2 minus 1 and 5 are added in, and in the replacement of 1 4 and 20, 2 minus 1 and 5, target sum is equal to 4. That's shrinking approach will not work, because by moving start plus plus increment might miss valid subarrays, because subtracting a negative number increases current sum. As we have seen that the current sum will increase, and it will say that the sum will be never the sum to, like example, the whole array is 2 minus 1 and 5. The sum will be the sum then the whole sum will be is equal to 6. So 6 is greater than 4. Shrinking removes 2. Let's suppose that shrinking will remove 2, and then it will move on to the minus 1 and 5. The sum will still be 4, correct? Okay, but the algorithm might skip this due to erratic current sum changes. What we can do is to improve this, like to add negative numbers also in our code, we can go with the hash map approach to store prefix sums. So it will work for n integers most of all. And yes, um, now I will be going to end this video, and I will also be going to dedicate each coding problems which are easy, intermediate, like medium, and complex hard. To each of these problems will be going into dedicated playlist of mine. So this problem will be going into easy, and furthermore I will be going to release more videos according to the difficulties, and they will be going into their dedicated playlist. So if you have understood anything from this video, please like and subscribe this video. It really means a lot, and